Constant acceleration formulae. Suppose we have an object moving with a constant acceleration a meters per second squared. When t is equal to 0, the object is at a fixed point O, moving with a velocity u. We know that v is the integral of the acceleration function with respect to t. And in this case, the acceleration function is just a constant. So in other words, it's just the value a, which in any particular case would just be a number. So that means v is equal to at plus some constant. Given that the velocity is u when t is equal to 0, and substituting that in, we get that c is equal to u. Therefore, v is equal to u plus at when we substitute the u back in for c. We also know that displacement is the integral of velocity with respect to time. And the velocity is a function of time here. It's this function, u plus at, where don't forget u and a are constants. So if we integrate that, we get u times t plus a half at squared plus some constant k. But we were given that the displacement is 0 when t is 0 because it started at the fixed point O. And substituting in s is 0 and t is 0 tells us that k is 0, and therefore s is equal to ut plus a half at squared.